So this is a very important and really practical question about training deep neural networks of all types, from multi-layered perceptrons, convolutional neural networks, or LSTMs, right? One of the very fundamental problems that you come across when you're training deep neural networks of all types is vanishing and exploding gradients. So the question here is, what all are the strategies that you know of across various neural networks, architectures, that can help us avoid both vanishing gradients and exploding gradients, right? And what are the strategies to deal with them? So let's break this question down, right? Typically for vanishing gradients in multi-layered perceptrons, even in CNNs, what we often do here is the traditional activation units were sigmoid and tanh, right? One of the problems with sigmoid unit is its gradient is always less than 1. So if you have a very deep multi-layered perceptron, it's very easy for you to run into this problem where the gradients would simply vanish when you backpropagate, right? Because you're multiplying many small numbers, right? Many numbers, all of which are less than 1. So one simple strategy to get rid of it, which is a very innovative, and I love that idea, which is the activation function called ReLU, right? So by just changing the activation function from sigmoid or tanh to ReLU is one way of sorting it out. Because in ReLU, you either have a gradient of 1 or you have a gradient of 0, making life much more simple, right? So you can avoid, and that's why ReLU has become, or variations of ReLU like leaky ReLU have become extremely popular in modern neural networks, right? So that's one strategy, which is change the activation function from sigmoidal or tanh units to ReLU or leaky ReLU type of units. That's one strategy. The other strategy, as we've learned in the course, is basically to add skip connections, like we learned it in ResNets, right? In a ResNet, right, you add skip connections so that you can literally jump from one layer to another layer, right? So adding skip connections will help you get into a situation where the gradients don't vanish, because the gradients can also jump across these skip connections, right? You may have 10 layers in between, right? So the skip connections is one very interesting strategy that will become very popular with residual nets or ResNets, right? That's one strategy of doing it. If you look at your LSTMs or GRUs, right, in your recurrent neural networks, one strategy that they employ, which is different from changing the activation function or adding skip connections, is having gates, right? Because you have a forget gate, because you have a cell state, and you have an input gate, because of this gating structure, you're ensuring that the gradients can pass without vanishing, right? It's a very neat strategy, right? So all of your temporal data analysis, or temporal networks like your LSTMs and GRUs, what they achieve using gating is also avoiding vanishing gradients, right? That's another strategy. So these are three broad strategies. There are other older strategies. For example, in one of the earliest neural network models, people used autoencoders to pre-train a model, to do layer-wise pre-training, which is no more popular today. It's not a very popular strategy today, but that would ensure that your weights are well initialized in a way. Also, there are certainly some advantages of having other strategies. For example, so in a nutshell, these are some of the strategies for ensuring that you don't have vanishing gradients. In a nutshell, for exploding gradients, a very simple trick for avoiding exploding gradients is called gradient clipping, right? If you notice that your gradients are very large, you clip it and say, my gradient cannot be more than a certain value, right? So gradient clipping is a very popular and simple strategy to avoid exploding gradients, right? Again, this answer is not exhaustive, but I'm touching upon all the key areas or the key strategies. For example, changing activation function to avoid vanishing gradients, very popular strategy because we have ReLUs, which we use all the time. Again, adding skip connections the way we do it in ResNets is a very important strategy. Gating that we've seen in LSTMs and GRUs is another popular strategy to avoid vanishing gradients. And gradient clipping is one of the simple strategies for avoiding exploding gradients. And throughout the course, we have discussed this in various parts in detail, because when we motivated why you need ResNets, why you need skip connections, we explained that it's useful because if if during backpropagation, if it is beneficial to have a larger weight on the skip connection, you can literally look at it as if the whole in-between network is nullified, right? Which basically makes vanishing gradient less likely, right? So all of this has been discussed to some extent in the course itself that we have, but this is at one place where we can discuss the spectrum of choices or the spectrum of options or spectrum of strategies that are at our disposal to avoid vanishing gradients and exploding gradients. At the same time, there is another strategy which is to initialize well, right? If you initialize your weights properly, if you don't initialize your weights to be too large or too small, right? If you initialize them sensibly, using various initialization strategies like Hay initialization or Glorot initialization, all these are initialization strategies that are extremely popular in deep learning. So also initializing your weights sensibly will avoid some of these issues for you.